All right, we're back with exam 1 review and additional items that you're going to have to learn for exam 1, excuse me. So this is video 6 part 2, tapers. We're going to be dealing with tapers. Actually, we're dealing with direct relationships, and that's what a taper is. It's direct. Pulleys and gears are indirect. Tapers are a direct relationship. Pulleys and gears are indirect. Tapers are direct. Now, easiest thing to do, well, I guess, I'll show you the taper sheet, your formula sheet in a little bit. All right, tapers are direct relationships, okay? Now, there are kinds of tapers. There's Morse tapers, there's Bruno tapers, there's the cat taper, which is named after the Caterpillar company. Those are the type of tapers that we use in our CNC machines. In this case, we have a taper. That means it's a constant angle. It reduces its diameter consistently for every lineal inch along the horizontal axis. Well, let's assume that here. Here, let's get rid of that. Let's go down the center line of the taper. Pretend that's the center line. I'll say it's the center line. That way it is, right? Okay. It's like Facebook. If it's on Facebook, it's got to be true, right? Not. All right. The most ridiculous thing on the planet. Facebook and Twitter. You're talking about a bunch of speech Nazis. If you don't think like they do, then they'll slam you hard. It's not very open-minded now, is it? Well, anyway, back to math. There are no isms in math. All right. We have a taper. That means it reduces its diameter consistently all the way along the center line of its axis. We have a 30 millimeter workpiece, and it has a tapered hole in it, and we're going to put this tapered plug in the hole. Now, all right, so our workpiece thickness, which happens to be 30 millimeters in this case, it looks like this. The relationship is going to look like this, all right? We said that the total length of the taper is 45 millimeters. From this point to this point is 45 millimeters. 45. Now, the total length of the taper from this point to this point in the workpiece is 30 millimeters. Now, that's got to equal something, all right? And we want to know what the total taper in the workpiece is. Now, the total taper in our plug, this plug, is 6.25 millimeters. That's the total taper. That's the total diameter it loses over its 45 millimeter length. That means that in 45 millimeters, it loses 6.25 millimeters in diameter. Now, we don't know what this big end is, and we don't know what the size of the small end is. But if we did know, and we subtracted the big from the small, we would get 6.25 millimeters. But for this story, this conversation, it does not matter. So we set the relationship up. Now, in a direct relationship, this belongs to that, and this belongs to that. The tops belong to one another, the bottoms belong to one another. Just do it. Do it and accept it. Now, we knew that when we did pulleys and gears, it was just the opposite, right? Because it was indirect. That belonged to that, and that belonged to that. But not here. Not in a direct. Not in a taper. This belongs to this. So now we set 45 millimeters in length. This is the total horizontal length. This is total horizontal length. It loses 6.25 millimeters. So we set this relationship up like this. Do it just like this, and you won't have a problem. We have an equal sign. So by now you ought to know that an equal sign says I can cross multiply, right? So we do. We cross multiply. So we get 30 millimeters times 6.25 millimeters. It's going to equal what? 45 millimeters times x. We're trying to solve for x, right? So 45 millimeters times x. Now, how do you undo multiplication? You do it by division, yes? So we're going to solve for x. So we take 30 millimeters times 6.25 millimeters, divide this side by 45, we divide this side by 45. The 45s go away. They go away. It disappears on this side. It's magic. That leaves us with X equals 30 millimeters times 6.25 divided by 45. Get your calculator out, or your abacus, or your slide rule, or whatever you're using. You do your math right, and you will get 4.1666666666667, depending on your calculator, how far it takes out your decimals, will equal X. And that's the taper in the workpiece. That's the taper in the workpiece. That's the taper in the workpiece. Okay? So, that's plain and simple. Doesn't get any harder than that. All right? Set the relationship up just like I did, and you will not have a problem. All right? Play the video back. Play it back, and you will see and follow the steps. Okay. Now, if we had a chart to fill in, and let's say that we changed the workpiece thickness to 40 millimeters. Well, it's still, the plug is still 45 millimeters long. It still has a total taper of 6.25, so whatever the thickness in the workpiece is. If it's 40, you'd put 40 down here, yeah? And still work it out the same way. That's the relationship for each one of these. Now, on the exam, it's going to ask you for the relationship. This is the answer in the exam for the relationship. Whatever the workpiece thickness is, whatever the length of the taper plug is, whatever the total taper in the plug is, that's the relationship. That's what it's asking for. That's what it's asking for. All right. That's what it's asking for. Now we go to a little different here. Right now you're going to ignore the formulas in red. We're going to work this two ways, and I'm going to show you how to do it two ways. All right, here we have a taper. The length of the shaft, the length of the taper plug is 12.5 inches. The large diameter A is 2.5 inches. It's 2.5 inches. The diameter of B, right here, is 0.75 inches. D, which is the length from the large diameter to the point that we're going to measure this with a micrometer, is 7.5 inches. And we're solving for the diameter of C. We want to solve for the diameter of C at point D. We want to solve for this diameter here, at D, at this point D. Okay? Now we're going to do this in two ways. The first is the relationship, like in the previous formula, right? Or the previous taper. So we have the length of the shaft, and we have a spot at D, a length at D, right? Okay. We have a large diameter minus the small diameter. So over this total length, if we subtracted the large diameter from the small diameter, we subtracted the small diameter from the large diameter, we would get our delta or our difference in diameter. Now, that's the same thing as the total taper lost over the total length. Yes, it is. So, and then we're going to solve for the diameter of at D, point D, which is X. All right, so we set it up the same way we did the other relationship. 12.5 inches is the total length of the taper, yes? Okay. 7.5 inches is at the point we want to measure the diameter, right? D is 7.5 inches. All right, let me clean this up. Let me get some stuff in here I put in here. There, okay. All right, so this is what we did before. So just do it. All right. Then we got 2.5 inches minus 0.75. That gives us 1.5 inches. Yeah? Yes, it does. Okay, so inches. There we go. Over x. So go ahead and do the math. You know what to do. You're going to cross multiply. So we're going to cross multiply. We end up with 7.5 times 1.5 equals 12.5 times x. We want x by itself, so we've got to divide 12.5 off of x. That makes that go away. Yeah. We divide 12.5 on this side. What we do over here, we have to do over here. So we end up with 7.5 times 1.5 divided by 12.5, and that is x. X is 0.9. This is not C. This is not your answer. This is not C. You'll see 0.9 does not equal 1.35, right? It doesn't. All right. So, what is x at D? X at D is the total taper lost from the large diameter to that point D, yes? At that length D. Does it not? The large diameter minus C equals x. So, we don't know what C is right now. We're going to solve for C. So we have to solve for C right now. So x equals LD minus C. So let's plug in the values. 0.9 was our x, yes? Just do it. Equals 2.25 minus C. Now, that means, how do we undo, this is a positive number on this side of the equal sign, right? We want C by itself. So what do? We have to subtract. This is a positive number, we got to subtract. So we're adding this number on this side of the equal sign. So we're going to subtract a 2.25. So this is what it's going to look like. 0.9 minus 2.25, because what we do over here on this side, we got to do over here. Okay, we do it here, equals 2.25 minus C. That's what we had here, right? It's the same. But we're going to subtract a 2.25 from this side. So what we do here, we have to do on this side of the equal sign. We jump the fence and do it over here. So now you have 0.9 minus 2.25 equals a negative C. Yes, this was a negative over here. So if it doesn't look like this, you're going to get the wrong answer. Just keep your signs, your negatives and positives together. So if you take 0.9 and then subtract 2.25 from it, you're going to get a negative 1.35. That equals a negative C. Now we have a negative equals a negative. That makes it a positive. It's magic. Just trust me. Okay? A negative equals a negative equals a positive. So the answer is C equals 1.35 inches in diameter. 1.35 inches in diameter. Now let us do it the other way. You might want to stop the video and play it back. My advice is you get a blank piece of paper and you write down every single step that I do exactly the way the sheet shows it. If you're having trouble, and follow through it. Don't forget anything. You're supposed to be a machinist. You're supposed to be precise. Just do it. All right? So, back up here in our chart, we have 1.35. Now, we calculated that what I would call the long way. Okay? What is this TPF? TPF is taper per foot. We haven't calculated that yet because we're going to do this two ways. We're going to do it the long way where we just set the relationship up, and then we're going to go and look at taper formulas. All right? All right. So we're going to do it the second way. So let's let us look at let's do it the second way. Let's do it the other way. Okay, come back up here. Okay. Now, go over to your master formula sheet. Master formula sheet. Master formula sheet. Now, in that master formula sheet, I think there's 22 pages. At least that's what this PDF reader says, we have a sheet of tapers. Now, yes, this came out of the blueprint reading book that we use in this program. All right, so we have a taper. There are all kinds of tapers. You can read all about tapers. Taper per foot is the amount of loss in 12 inches in a foot. We call it taper per foot. Now, just accept it. SD is the small diameter. Large D is, LD is the large diameter. Length is the length of taper. TPF is taper per foot. And here's your taper per foot formula. LD minus SD times 12 divided by L. Now, I was nice and I algebraically rearranged all this for y'all. Merry Christmas. So if you're looking for L and you know what your taper of foot is, then you can use this formula. If you're looking for the small diameter and you know everything else, including the taper per foot, then you can solve for the small diameter using this formula. This one right here. Oh, God. I have to get a draw on this one, too. Come on, draw. There we go. Okay. Like I said, if you're looking for the small diameter and you know what the large diameter is, you know your taper per foot, because you calculate taper per foot up here, maybe you have the data, then you're going to use this one. If you're looking for the large diameter and you have the small, the taper per foot, and the length, you're going to use this one. And 12 is 12 inches, 12 inches per foot. Okay? Now, and yeah, there's some redundancy in here, so you can read this all on your own. So let's go back to the other exam notes. All right, so first thing we're going to do is we're going to find the taper per foot, because we were given the large diameter. Yeah, this is large diameter, this is small diameter. So A is the large diameter, and B is the small diameter, and we know what the length of the taper is, right? So we have everything, large, small, length, and taper. So we can figure out taper per foot. So let's do that. So we got 1.5. So for taper per foot, what do we have? What do we do? We got 2.5 minus 75, right? Remember that? Large diameter is 2.25. 2.25 minus 0.75. All right, so this equals what? 1.5? Okay. Of course it does. So there's 1.5 times 12 divided by the total length, which is 12.5. So our taper per foot is 1.44. 1.44. Now, so taper per foot, doesn't matter anywhere in here, our taper per foot for this taper is 1.44. Right? Okay. Now, we want to know what the small diameter, because C now represents the small diameter at D, does it not? D is a new length. D is our new length. We want to know what C is. So C really is the small diameter of just this piece of the taper, right? Here's the large diameter. This now is the small diameter. This is now the new small diameter at this length D. So plug it in. We're looking for small diameter, right? What's the formula for small diameter? Large diameter minus the taper per foot times the length divided by 12. There's a parentheses there, so we're going to do everything in here first, right? Remember your PEMDAS? So you got 1.44 as your taper per foot times the length at D. And what is the length at D? What is the length at D? D is at 7.5 inches, yes? So that's 1.44 times 7.5 divided by 12, right? minus 2.25. So work the math out. So that's 144 times 7.5, 1.44 times 7.5. That's 10.0, that's 10.8 divided by 12. So that gives you the 0.9. That gives you 0.9 in here. In here, this equals 0.9. Where did we see 0.9 before? That's right here, isn't it? Okay. Minus 2.25, which is what we did over here, right? Okay. Minus 0.25. And lo and behold, what do we get? We get 1.35 inches. Same answer we got. Doing it the relationship way is the same answer we get when we use the taper formulas. Okay? All right. There's two ways to do it. So if you've got taper per foot, if you have taper per foot, and you can solve for taper per foot, then you can solve anywhere in here. Now, remember, we're not looking for this small diameter. We know what it is. We're looking for this new small diameter at point D. And D is at 7.5 inches from the large diameter. Okay. Now, so if you were given a chart with different variables in, you might just have to do 4 or 5 of these, and they're all different variables. The lengths will be different. The large, small diameters will be different. If you can solve for taper per foot, then you can do that, and then find that new small diameter at the distance D, whatever that might be. There may be 4 or 5 of these. If this is millimeter, if it's metric, you don't have to convert the metric to inches. Believe it or not, trust me, you don't have to convert the metric to inches. If you've got enough to solve for taper per foot, you can do that with the data you're given. Then go back, solve for the new small diameter. You just know that it was going to be a large number. It might be 80, it might be 75, but that's millimeters, that's not inches. Okay? So this should be enough to get you started. The exam is up on D2L. You should be able to go through it and start working the problem. If you have a question, you can email me. If the question is significant enough, then I'll send it back to the whole class, the answer, the question and the answer. Because chances are somebody else has that same question you do. Play this video back over and over and over again. Again, that's the advantage of having the videos as opposed to face-to-face, and then me putting you to sleep with my monotone voice. All right, now let's look at another relationship. We already probably figured out, or maybe you figured out, if you haven't, you should have, that a fraction is nothing more than a relationship, right? If you hadn't got that far, then you're in bad shape. So let's, oh God, here we go again. Go to the marker. Let's do black. If we got 1 over 2, and we turn this into a decimal equivalent, we all know that that's 1/2, right? Or 0.5. Well, if we multiply that times 100%, because 100% is 100%, right? We get what? We get 50%. Same way with 1 over 1/4, or 1 over 4, 1/4. That's 0.25 times 100%. The 100 equals a percentage. Then that is what? 25%. Okay, 25%. All right. All right, let's go back over here. Let's look at another relationship. Here's a formula. P over B equals R over 100. Where P is the base, or the denominator, it's the base of what we're talking about. P is the part of the base, or the numerator. It's the part of the base. And R is the rate, or percent. And we know that 100% is all you're ever going to get. Now, you had 120%, then it would be more than 100%, right? You're going in the positive direction. Let us say that an alloy is made up by weight, 60% copper, 38% tin, 1% manganese, and 1% other. Now that should all equal 100%, right? 1 and that's 2, that's 40, that's 100. So for 3,000 pounds of an alloy, there is how much copper, tin, magnesium, or manganese, and other? Well, this is really simple. You set it up. Copper, P over B equals R over 100. So we want 3,000 pounds of alloy, right? So our base, or our denominator, is 3,000 pounds. 3,000 pounds right here. 3,000 pounds. Our P is what we're trying to solve for. How many pounds? Okay. What's the rate? How much copper is in our alloy? We said it's 60%, right? So you put 60% over 100. You do your cross multiplying, right? You do your cross multiplying, and what happens? 60 times 3,000, so that's 60% times 3,000. P times 100 over here, so that's P times 100 equals 3,000 times 60%. And what are we going to do? We're going to divide, excuse me, we're going to divide 100 from this side to get the P by itself, right? Remember? We're going to divide 100. That makes that go away. And take 100 over here. And that gives us P equals 3,000 times 60 divided by 100. Okay? And work that out, and what do you get? Oh, you get 1,800 pounds of copper. Yeah? Now do it for tin. The same way. Tin's 38%, right? So it's 38 times 3,000, P times 100, divide the P by 100, divide the other side by 100, and you end up with this right here. So you do the math, and you end up with what? How much tin do you end up with? You end up with that much tin. Okay? The copper, we ended up, took the 1,800, put it up here in this chart. Yeah. You do the same for manganese, you do the same for other, and you should end up with 30 pounds of manganese and 30 pounds of other. And that should all equal 3,000 pounds, and you add all that up and you check it. All right. So you're going to do the same for manganese, and that's going to give you, and the same for tin. Okay. Or same for other. All right. Let's look at another relationship. So I can find my cursor. Okay. All right. Total production cost. The total production cost is $250,000. Okay? And we do the same breakdown as we did up here, right? Labor was 38%, materials is 50%, and our overhead is 12%. So you do the same thing. It's P over B, the part, over B, equals the rate over 100. Now what's our base? Our base is $250,000, right? That's $250,000. So we're looking for P. So it's P for the first one over 250,000 equals, so we're going to do labor. What's 38? Labor's 38, right? 38% over 100. Okay, we're going to cross multiply. Cross multiply. Bingo. And we get P times 100 equals 38 times 25. K. K is 1,000. So it's 25,000, 250,000, 250K. All right, that's equal. Now you already know the drill here, right? So we're going to come up here. We're going to divide this side by 100. We're going to divide this by 100. There's an equal sign. The hundreds over here go away. That gives us P equals 38 times 250,000 divided by 100. So that should give you $95,000. This should equal $95,000. Equals $95,000. Okay, so let's check that, make sure it works. 38 times 250,000 divided by 100. Wow, looky there, $95,000. So that's real simple. You take that number and you plug it up here, right? And you plug it into there. Do the same for materials and the same for overhead. And these numbers, you should get these numbers. All right. This video is running about 33 minutes so far. Let's look at this one. Some people get this all screwed up because they can't get their head wrapped around the fact that the P is greater. All right. If a company's earnings this year are 175% greater than last year, this year they earned $2,225,000. What was last year's earnings? We don't know what the base of last year's earnings were, do we? Okay? But you still set the relationship up. Okay? Last year's earnings is now the base. That's what we're trying to solve for. We're trying to solve for last year's earning, the base. That is what everything else is measured against. Okay? So we're trying to solve for B. We don't know what B is. We do know what this year's is. This year's is 2 million. So the part of last year's base is greater by 100. It's 175%, right? All right. It's 175% of last year. So you take this year's part, 2,225,000. You put it over B. The rate of this is 175% compared to last year. Okay. You cross multiply. You cross multiply. 175 times B. We're going to divide this side by 175. We know that because we want B by itself. That cancels the 175s out. Equals 2,225,000 times 100 divided by 175. You do the math, and you should get last year's earnings of this right here. Now, I'm not going to do the math for you. You're going to do it. You got a calculator. All right, so you should get that number. So that's the answer. That's what they made last year. That's what they made last year. Okay. They made 1,278,428.571. And that's the answer to the problem. Okay. That's the answer to the problem. All right, let's see what else we got. It should be page 10 of 10. This is the last time. Okay. Here's a production problem using the relationship of PB and R in 10, and a rate in over 100. Total time to ream and thread a 30-inch target barrel is 5.25 hours. That's total time. If threading takes 1.75 hours, what percent of the total time is spent on threading? So 1.75 is your threading time. The total time to do the barrel is 5.25 hours. So we set it up. P over B equals R over 100. That is your parent formula. Go back to that formula. The part of the total time is 1.75 hours. Total time to finish it is 5.25 hours. So that's your base. We want to know what the rate is, right? So it's 1.75 times 100. You cross multiply again. R times that. That gives us 5.25 times R. We know we're going to divide this side by 5.25 because we want R by itself. What we do over here, we have to do over here. So we take the 1.75 times 100, divide by 5.25. Do the math. You do the math. You do the math. And 1.75 times 100 divided by 5.25, that equals 33.33%. Okay? 33.33% is the answer to the problem. Now, another way to do this is just divide 175 by 525, the shortcut way. I would suggest you go back and use this formula until you get used to doing these things. You set these up, you'll know what you have, you'll know what you don't have. You have the time to thread it, total time to finish it, you're solving for this, you know that stays constant. This is the safest way to do it. The safest way to do it. This is the safest way to do this. This is the safest way to do this. But if you think you're an F-16 fighter pilot, you can do it like this. You get a .333, and you know you got to multiply that times 100%, turn it into a percent, and then that's your same answer there. Okay? All right, that ends this video. This thing's running at about 39 minutes. Okay. All right. So this is part 2 of the exam 1 review and the lecture series for direct and indirect relationships. Play this video back. Get you a blank sheet of paper, play both videos back, get you a blank sheet of paper, come up with the same answers that I've got, and you should not have a problem on the exam. All right. Remember, when you do the fill-in exam, you're going to print it as a PDF and send it to me non-fillable. I think that should be it. All right. Well, good luck.